Hello friends, today we will learn about support vector machine algorithm. So what is support vector machine? Support vector machine is one of the most popular supervised learning algorithms which is used for classification as well as regression problems. So the main goal of SVM algorithm is to create the best line or decision boundary that can segregate the dimensional space. SVM chooses the extreme points of vectors that helps in creating the hyperplane. So what is a hyperplane? As you can see, this is the line which is called hyperplane. Above it, it's called positive hyperplane, whereas below it, it's called negative hyperplane. It basically divides the data into two types, two categories, which are required for the classification process. As you can see, these are the support vectors, and this is the maximum margin hyperplane, which divides the green dots and the blue squares into two parts. Now we will learn about support vector machine algorithm. It can be easily understood by this example. So first we're gonna see this example. We will first train our model with lots of images of cats and dogs so that it can learn about different features of cats and dogs, and we can test it on a strange creature. So our support vectors create a decision boundary between two data sets. Like as we have discussed below, it divides into two planes. So as the vector support vector creates a decision boundary between the two data, choose extreme cases, and in this case the extreme cases are cat or dog, whether it's a cat or a dog. So as you can see in this image, we put the data of a cat and a dog and do the model training with lots of images, and then we can predict our strange creature, whether it's a dog or a cat, and this algorithm gives us the output, whether it's a cat or a dog. So SVM algorithm, it is basically used for face detection, image classification, and text categorization, etc. So there are two types of SVM. One is linear SVM and other is non-linear. In linear SVM, we can divide the data into two parts, whereas in non-linear, we cannot do that. It cannot be classified basically by a straight line. So now I'm going to show you my notebook code which I have written for support vector machine algorithm, and yeah, this is my notebook. I have written this code for you. So I will explain you the process of support vector machine. This is a stepwise representation on how support vector machine works in very easy language. It's given below. So first we are going to import various libraries which are required for the process. So the second process is that we read data from the CSV file. The CSV file contains all the data. Like before the prediction process, we make this model to learn. So we are going to read this CSV file which contains all the data. The CSV file should be present in the home page directory, and as you can see, it's here, social media, and it contains all the data we need for the data processing. Okay, so as we read the CSV file in the third step is the reading of the CSV file to the partishing of data of input features and target data. So basically we're gonna divide it into two parts, input features and target data. So this is the location, and by the syntax we can mark the location from where we need our input features and target data, and later we train the model by dividing it into X train, Y train, and testing datasets into X test and Y test, and by taking the size 0.3. So if we take size as 0.3, so we're gonna take it into 70% and 30%. But if it's 0.2, we will take it as 80% and 20%. It depends upon the data we need to do, and it entirely depends on you which size you want to take. So we have already done this. Now our next step is to train our model. So this is the model, this is the code for making the prediction of the model, and here is the result. So these results are achieved by doing this entire process. So I have used some, as you can see, I've used some parameters here. As you can see, kernel, C, gamma. So what are these hyperparameters that are used in SVM? So kernel parameter basically is used to separate the data. Using linear, will use a linear hyperplane. As we did it in my, as I've shown you in that image, it was a linear hyperplane. It was in a straight line. Okay, so C, it basically controls the trade-off between smooth decision boundary and classifying training points correctly. So if we use C is equal to 100, it will show you the best result. So the other one is gamma. It defines the how far the influence of a single training example reaches. It has a low value. It means that every point can feed far reach, and conversely high value of gamma means that every point has a close reach. It's inversely. So basically we use it as 1. Gamma should be 1. For obtaining the accuracy of the model, we use the score to predict that how accurate our model is. That's it. You can try this code on your own to learn SVM, and you can contact